Hello, dividing polynomials. What we do in this first bit is we rely on this principle. So you know this. When you're adding fractions that have a common denominator, a over c plus b over c, you keep the denominator and you just add the numerators, right? So what we've never done is we've never done that backwards because we've never had any reason to. So we want to take stuff that looks like this and split it up into stuff that looks like this. Obviously, if it works forwards, it works backwards, right? Now we actually have a reason to do it backwards. So here's what I mean. Divide and simplify. 21x to the fourth minus 18x cubed plus 12x squared over 3x squared. All right, so this is a polynomial divided by a monomial. Dividing by something that's not a monomial, you're going to see as a whole different bag of chips. That's not an expression. Okay, so the first thing to do is to use this principle. So this is like a plus b plus c over d. We can split it up. We're going to split it up into three things where it's just 21x to the fourth over 3x squared minus 18x cubed over 3x squared plus 12x squared over 3x squared. Like that. So if you believe that these three separate terms can be written as this one thing because they all have a common denominator, then you have to believe this, right? You can do it one way, you can do it the other way. So now keep in mind that only works when you have, it's over a monomial. If it was over a binomial or something, you're going to see it's much harder. But I would do it this way. So be careful not to just start factoring stuff out of this thing right away, because we haven't really discussed factoring, and you have to be sure that you're doing it out of every term. So if you do that and you do it right, I can't mark it wrong, but just assuming this is the first time you've seen this, do it this way. Split it up, and then you know how to simplify individual fractions. So you're just going to simplify the 21 and the 3, and then do something with the exponents here, some with the exponents here, some with the exponents here. So 21 over 3 is 7. So just go term by term. So it's 7, and then the quotient rule for exponents says it's 4 minus 2. And then it's 3 minus 2, 18 over 3 is 6. And then these x squareds do just completely divide out. Or you can say 2 minus 2 is 0, so it's x to the 0. And then the 12 and the 3 simplify to just a 4. Okay, and then just do the exponent math, which you could probably have done in your head. 4 minus 2 is 2, 3 minus 2 is 1. So there you go, 7x squared minus 6x plus 4. And that's as good as it's going to get. Okay, so when you divide a polynomial by a monomial, you get some other polynomial. And that's not that bad, so try a couple of those. Here's where we get into the tough part. And, I want to make sure I show you a couple solid examples of these, but this is a lot of algebra. And yes, you have to use long division on a polynomial. So I need you to remember how long division works, especially when it pertains to like the remainder. This is exactly the same thing. It's just you're not using numbers. You're using polynomials. You'll see. Okay, so first problem, divide 6x squared plus 9x minus 10 by 2x minus 1. Okay, how the heck are we going to do that? Well, the same way you divide a number by another number. You're going to pop it into those one of those little long division-y things, and then I'm going to show you. Okay, like that. So there's no way for me not to handwrite these, so hopefully you can read that. So remember that this expression means 6x squared plus 9x minus 10 divided by 2x minus 1. So now think about how long division works. So ignore the minus 1 for the moment. What you're doing first is you're looking for what number you have to multiply this first term, so just the 2x. What do you have to multiply 2x by to get 6x squared? And another way to say that is, what's 6x squared divided by 2x? So you need a 3 to make it into a 6, and then you need an x to make it into an x squared. So the answer is 3x. Okay? If you do 2x times 3x, you're going to get 6x squared. Okay, so remember that. It's going to be 3x. Again, don't worry about the 1. Just only worry about the kind of leading term here. Remember, with long division, you want to line digits up. So since the first thing we put up here is going to be a 3x, we want it to go with the x term of this. So we want the 3x to line up with a 9x. So you're going to put a 3x right here. And then remember what you do. You multiply 3x by this entire binomial. So that part's a little different. Like I said, you're kind of ignoring the -1. You're just worried about the 2x. You put a 3x here, and then you do 3x times this entire thing. Like that. Okay, so 3x times 2x minus 1 is 6x squared minus 3x. So in most senses, this is exactly the same process as a long division. And I know you hate this, but we have to do it. Okay, now remember the next thing you do in long division? You subtract. And a word of warning here. You're subtracting this entire term, this entire binomial here, 6x squared minus 3x. So I would put parentheses around it. Like that. It's super easy to make a mistake in this part. So just be really careful. When you subtract it, right, this is actually 9x minus negative 3x. That would be really easy to miss. So the first term should go away if you did it right. 6x squared minus 6x squared is 0. 9x minus negative 3x is 12x. And then remember the next thing you do in long division, you bring the next digit down. So in this case, you just bring the next term in the dividend down. Okay, so the negative 10 comes down. Now you repeat. So just go back to the 2x, don't worry about the -1, and then look at the 12x. How many times does 2x go into 12x? Well, that's the same thing as saying what's 12x divided by 2x, and that's 6, right? So we need a 6 to get from 2x to 12x. So that 6 goes here, and it will already line up with the 10 digit. Okay, so put a 6 here and multiply. 6 times 2x minus 1 is 12x minus 6. Subtract again. And again, use the parentheses. So it's going to be 12x minus 10 minus 12x minus 6. And the 12x's go away. Negative 10 minus a negative 6 is negative 10 plus 6, which is negative 4. Almost done. And now you have to remember what happens to the remainder. So if that helps you, go back and do a long division problem where we got a remainder. The remainder now goes over the original divisor. So the quotient, like your answer, is 3x plus 6, and then it's always plus the remainder over the original divisor. This would be like if you got a 2 at the end, so that means you had a 2/3 or something. So it's going to be 3x plus 6 minus 4 over 2x minus 1. Okay, I know that seems like a lot. That's the most algebra we've done yet. And so you have to trust the process, and then you have to remember the process. Remember what the remainder means. Remember where it goes at the end. It's not just a error or whatever. It goes over the original divisor. So what I'm telling you is that 6x squared plus 9x minus 10 divided by or over 2x minus 1 is this. You could multiply 2x by 1, 2x minus 1 by your quotient to see that it does in fact simplify to this original dividend, but that might be more work than it's worth. You might just have to be confident and trust yourself. Okay, I'm going to do another one of those because I know that they're hard. Okay, so here it is. This one's even harder. 7 plus 2x to the 4th plus 5x squared over x squared plus 2. So notice there's some different stuff here. We got a higher degree in the numerator, and then there's a higher degree in the denominator as well. The denominator actually has an x squared in it. So don't just jump right in and start long divisioning. There's actually 2 things we have to do before we even start. So the first thing is notice that the numerator just isn't in the nice order that we like, the descending power order. So put it in that order. And then there's another thing. So you're going to write the thing on top as 2x to the fourth plus 5x squared plus 7. Fine, that's easy. And you do have to do that. It does have to be in that order, standard form. But then also, you wouldn't know this, but you have to fill in the missing terms. So there's no x cubed term here, and there's no x term here. So you have to actually put them in with zeros, like this. So any missing terms in your dividend, in your thing that you're, well, the numerator, the dividend, have to be filled in with zeros like this. Okay, so we have 2x to the fourth plus 0x cubed plus 5x squared plus 0x plus 7. And I know that looks weird, but it has to be like that because think of those zeros as like in a decimal. If you're dividing a decimal, you'd have like, 2.002 or something. Those zeros are kind of just placeholders that put the other digits in the correct place. So that's what these do. They make sure everything lines up. Okay, so we're dividing 2x to the fourth plus 0x cubed plus 5x squared plus 0x plus 7 by x squared plus 2. Okay, so here we go. So now it's the same as last time. So it was just that bit of setup. All right, so that means this divided by that, and here we go. We got to think of how many times does x squared go into 2x to the fourth? Or what is 2x to the fourth over x squared? Well, it's 2x squared, right? We need a 2 to get it to 2, and then we need an x squared to get it to x to the fourth. So that's your first term that's going to go up here, is a 2x squared. And now, again, line it up, right? It's got to be lined up with the x squared term. So that's going to go here. So a 2x squared is going to go there, and then we're going to multiply. Okay, so 2x squared times x squared plus 2 is 2x to the fourth plus 4x squared, but you want that to line up here. Don't put the x squared term under the x cubed term because they're not like terms, so they won't subtract correctly. Okay, so just throughout this whole process, just line up the powers. Now we subtract and bring down a next term. So always use the parentheses when you subtract. The first term better go away. 0 minus nothing is nothing. Now we have a 5x to the fourth minus 5x squared minus 4x squared. See, this is confusing. Which is x squared. Okay, so the parentheses made this a minus sign. Now we have to bring something down. Since there's nothing here to bring down, that's fine. You can go ahead and bring down the 7. You'll see that even if you didn't do that in this step, you'd end up doing it anyway. So this is faster. Okay, so if there's a missing term, go ahead and bring down the 7. Almost done. Now we say, okay, what do we need? How do we get from here to here? What do I have to multiply x squared by to get x squared? Well, it's just 1. Right, so the next thing that's going to go up here is just a 1. So line your 1 up with this 7. Line up the places. Okay, so I have x squared plus 2, and you're going to subtract. So you see how it just lined up automatically? It worked out. You subtract, you get, okay, this is, these terms go away, and then we're just left with a 5. 5 is the remainder, and the remainder always goes over the original divisor. It's hard to remember which one's the dividend and which one's the divisor. I forget a lot too. So your answer, your actual quotient is 2x squared plus 1 plus 5 over x squared plus 2. Okay, so what I just said, 2x squared plus 1 plus 5 over x squared plus 2. And that's that. Okay, so please try some of these on the homework. I'm going to put one of these on the test. If you can do this, then you are in good shape algebraically. I was actually surprised this is even in this course because this is some real algebra. Okay, In fact, I think the class gets a little easier after this section. So hang in there with me, okay?